Good evening, everyone. My name is Sridhar, and I am from CSEF section. And for the complex engineering problem, mathematics for computing, my topic is about permutation in scheduling tasks. And now let us discuss about the how permutations are used in the scheduling of tasks. Now let us discuss about introduction to permutation in scheduling tasks. Permutations involve the arranging tasks in different orders to optimize scheduling outcomes. They are fundamental in understanding how task sequences impact overall efficiency. This presentation explores the role of permutations in task scheduling optimization strategies. Here, the introduction is all about the permutation in charted scheduling tasks, which are like permutations is nothing but which is involving in the arranging tasks in different orders to optimize scheduling outcomes. They are fundamental in understanding how task sequences impact overall efficiency. And also, this presentation explores the role of the permutations in task scheduling and also optimization of the strategies. And now, what are permutations? So basically, we need to know about the word of permutations. Permutations are arrangement of objects or tasks in specific order, and arranging arrangement of the objects or tasks in a specific order is known as permutation. The order of tasks significantly affects the scheduling result and also resource utilization. Here, of course, the order of the task always affects the scheduling results and resource utilization. Permutation differ from combination and which focuses on selection without regard to the order. Here, the combinations are different from the combination. However, in combination, we do the arrangement of the objects, and in combination, we select the objects from a group of objects. Importance of scheduling tasks. Here are some of the importance in scheduling tasks, such as effective scheduling, which maximizes the productivity and minimizes the delays. Here, the effective scheduling maximizes the productivity, which also helps in high efficiency and also minimizes the delays. And the proper task order can reduce resource conflicts and idle times. By properly giving the tasks on the order can also reduce the conflicts and idle times. And also now permutation helps identifying the most efficient task sequence of tasks. Here are some of the basic principles for permutation in scheduling. Permutation, the total number of permutation depends on the number of tasks to be scheduled. Factorial notation in factorial often represents the total permutation for n tasks. Understanding the total permutation helps in exploring all possible tasks and sequences. Here are some of the task sequences, such as the permutations. Basically, the basic principle of the permutation in scheduling is to that the permutation only depends upon the total number of tasks to be scheduled, which having the factorial notation, which is like n factorial. Permutations with constants. So constants such as dependencies influence feasible permutations. Not all permutations are valid if certain tasks must precede others. Adjusting permutation for constant ensures realistic and practical scheduling. Here are some of the permutation which are having the constant, which are like adjusting the permutation for constant ensures realistic and practical scheduling, and also not all permutations are valid and also which are like precede some of the others. And then we see about the permutations in single machine scheduling. Which are like the permutation are used to determine the optimal order of tasks and on a single machine. A technique such as Johnson's rule helps in sequencing with two or more objects. And also the goal is to minimize make span and total completion time. On other criteria, we are like these are the what do you call the permutation which are like single machine scheduling, where the permutation will use it to determine the optimal order, and also which is on the single machine. We also use the Johnson rule, which is the most important rule in sequencing the two or more jobs, and also the goal is to maximize the make span and the total completion, which is like most important in the single machine scheduling. Permutations in parallel machines. Tasks can be assigned to multiple machines, increasing complexity of permutation. Strategies involve balancing loads while considering task order permutation. Optimization algorithms help find the best permutation for parallel processing. Here, there are like some of the uh, permutations and parallel processing, which are like using the tasks to be assigned in the multiple machines and also increases the complexity of permutation. Strategies which involve balancing loads while considering task order permutation, which optimizes the algorithm, which helps in the finding the best permutation for parallel processing. Now, let us discuss about the thing which is like permutation algorithm techniques. Permutation algorithm techniques such as algorithm like backtracking systematically explore all possible permutation heuristics and approximation methods provide a near optimal solution efficiently. Also, genetic algorithm and stimulated annealing are popular for complex scheduling problems. Here, some of the permutation algorithms, such as backtracking algorithm, which is like most important, like most usually systematical algorithm, which used in the for all possible for permutations, and also heuristic and approximation method, which also used for near optimal solution efficiently. And also genetic algorithms and stimulated analytics are one of the things which are using for complex scheduling problems. Examples of permutation calculation. Here are some of the examples which are having considering three tasks with no constraint. Total permutations are 3 factorial, which is like we know that 3 factorial is 6, and each permutation represents a possible sequence to evaluate for efficiency. Analyzing permutations helps select the best task order based on the criteria. Here are some of the criteria where like for example we are taking three tasks which are like ABC and having the total permutations are like 3 factorial, which are like we can arrange the three things such as ABC in three six possible ways like AB, AC, and BA, BC, and so on. So these are the 6 ways where you can arrange those things. And also each permutation represents a possible efficiency, and analyzing this helps in select the best task order based on criteria. And also permutation and optimization objectives. Here, like some of the objectives include minimizing total completion time, lateness, and tardiness. Permutations are evaluated to find the sequence the best meets this goal, and multiple objective optimization may require balancing different permutation outcomes. Here are some of the optimization objectives, such as like objective includes the minimizing the total completion time and the lateness and the tardiness, but also the evaluated the finding the best sequence which means the best where these goals. And also multi-objective optimization may require the balancing permutation outcomes. And also then now let us discuss about the real world application of permutation in scheduling. Manufacturing plants optimize assembly line sequences for efficiency, and then computer processors schedule tasks to improve uh, performance and reduce latency. And also now the project which is like likely to be computer processor schedule tasks to improve the performance and the reduce latency. Project management tools use permutation to sequence activities effectively. We use some of the tools such as like permutation, which most projects are used to sequence activities effectively and also efficiently. Now, challenges in managing permutation. There are like a large number of tasks lead to factorial growth, making exhaustive search impractical. Constant and dependencies further complicate permutation analysis. Advanced algorithms are necessary to handle complex scheduling permutations effectively. Yes, some of the challenges in managing permutations, which are like a large number of tasks are exotic, making exotic such impractical, and also some advanced algorithms are necessary to handle the complex scheduling permutation effectively. And then future trends in permutation based on scheduling. There are like some of the future trends like such as integration of artificial intelligence for dynamic permutation optimization. So like integrating the artificial intelligence nowadays, artificial intelligence are like integrating into everything. So and also integrating this artificial intelligence for dynamic permutation also better for the optimization, and then use of machine learning to predict optimal task sequences based on historical data. And also development of real-time scheduling systems that adapt permutation on fly. And then now we'll discuss the summary and the key takeaways, such as permutations are crucial in exploring all possible task sequences in scheduling. And also proper analysis of permutation can significantly improve scheduling efficiency. Combining these permutation techniques with optimization algorithm leads to better decision making. And these are the some of the references like Pedeno, the scheduling theory algorithm, and system Springer, and also the some of the things like introduction to algorithms and MIT Press with optimization techniques in scheduling. And this is all about the permutation which are used in all the things. Thank you.